Hello everyone and welcome to the course Climate Hazards and Disaster Mitigation. Today we are going to summarize our discussion over the past 3 lectures on hydroclimatic and geospatial data processing. So what have we learned so far? We understood measurement of hydroclimatic data and their characteristics. We discussed various hydroclimatic and geospatial data types and their sources. We explored the role of remote sensing and GIS in disaster mitigation and management through case studies. So what are our objectives for today? We'll present a comparative assessment of the data types for hydroclimatic measurements. We'll review the applications of hydroclimatic data in analyzing climate extremes, and we'll comprehend the importance of remote sensing and GIS in disaster mitigation studies. So just a quick recap that why hydroclimatic measurements are important. They are used to study the interaction between climate and water on Earth, because they include variables like precipitation, temperature, wind, humidity, pressure, storm surge and other atmospheric variables. So if we have information on this, we can use it for planning, we can use for design of hydraulic structures, we can use for water resource management and for other research purposes. So coming to the basic types of data, to start with, we have in situ data. So in situ data includes direct point-based measurements. So you have point-based measurements, it can be from a sensor or stations. So these point-based measurements can help you get information on rainfall, soil moisture, temperature and other parameters. Then we come to your gridded observational data sets. So your point-based data sets are then converted into by interpolating into a spatially consistent data set. So the advantage over gridded data set is that you get uniform spatial coverage, where point data sets can be sparse in some regions and more in other regions, so that is overcome. Also they are more consistent, so the missing data is also overcome by combining so much information. Then you have remote sensing products. Remote sensing products are those which are retrieved from satellite observations over the land, ocean and atmosphere, or from drones. So these data sets, the advantage is that we can get information in real time as compared to other data sets. Of course, if there is a telemetry station in situ, that can also transmit real-time information, but remote sensing also gives us real-time information over a larger spatial extent. Then comes reanalysis data. This is a long-term consistent climate data set by blending the past data with some model forcings, and coming to the gridded projected data sets. So this is again a high resolution future data sets resulting from projections from various climate models or various other models relating to population forecast, etc. So coming about the point data, so these are based on the ground-based sensors or soil probes, which directly measure the conditions at a particular location. So the very importance of in situ data is that if you have different sources of data like reanalysis data, satellite data, so there are some sort of bias present in the data. So if you want to correct them, then this can provide accurate ground truth. So that is where it is important. So we have rain gauges for precipitation measurement, then ground-based sensors for soil moisture. We can use monitoring wells or stream gauges, or even nowadays sensors and that is photogrammetry is also used, that is image analysis for water level measurement, then water quality and then other meteorological variables. Remote sensing data, you can get either satellite imagery or aerial imagery, then you can have oceanographic information, then you can get land and atmospheric products. So there are a very large source of remote sensing data that is developing, and you have optical and radar images which will give you very precise information about the land cover, about the atmospheric processes happening, and other information which is useful on a larger scale. So gridded data, it represents your point observations or any other observation into a very spatially consistent format. So you can see that these grids represent at each grid is represented by a combination of a latitude and longitude. if you have if you include a third parameter of elevation, then it can be at different heights, like different geopotential heights you can get those variables, like air temperature varies, so at different heights if you want to represent, then you can use this gridded data. So raster format also we discussed when we are talking about geospatial data. So that is the value which is contained in a particular cell or a grid. So that is again a type of a gridded data format. Reanalysis data. Now reanalysis data is more robust in the sense it provides you long-term and consistent information of several parameters, because it uses observations, it combines with them with certain models, and does data assimilation and then creates this reanalysis data product. So one such product which is indigenously developed is ILDAS. So it is developed by a team at IIT Delhi. So this will also give you very robust information about the Earth observations. Next is a projected data set. So here you can get informations from global climate models or regional climate models, and these information you can get projections till future, that is 2100, that how the climatic parameters are going to behave, and they are widely used for policy analysis, that if you want to have long-term policy solutions, then you can use this. Similarly, you can have projected land use. Depending upon your growth pattern, even the land use can be projected, so that kind of data sets are also available. Using all these data sets, particularly the hydroclimatic data sets, we will derive rainfall, extreme rainfall and temperature indices. So these indices are nothing but the quantitative measures which will give you an idea about the different characteristics of the precipitation. Here we are using a generic word rainfall, because in India most of the amount of precipitation that is coming through rainfall, but precipitation is a more generic word. So it can be used to analyze intensity, frequency and duration changes in the rainfall. So we can adopt it for climate change analysis, flood and drought assessment, agriculture planning, water resource management, and some economic analysis as well. So let us understand the schematic. So this is a simple rainfall data. Now IMD specified that any value greater than 2.5 millimeters in a day is quantified as a rainy days. So if we put that threshold, whatever we get, that is rainy days. So we make a count of all rainfall values greater than 2.5, that is called our rainy day. Now if we add the magnitudes on these rainy days, it becomes a total annual rainfall, that is PRCP, where we are summing up the magnitudes. Then if one maximum value of all will become the 1 day maximum rainfall. Now there are consecutive, you can see from the plot clearly, there are consecutive wet spells and consecutive dry spells. So these can be quantified, that we will count the number of consecutive wet spells that is greater than 2.5 millimeters. These are wet days, and the maximum of those wet days will be your CWD, that is consecutive wet days. Similarly, you will compute the dry spells, and the maximum of those dry spells will be your CDD. So here the CDD is 6, and in this case your CWD is 5, that is the maximum 5 wet spells occur. So this way we also discussed extensively several more indices, and that can be calculated very easily using this approach. Similar to that, temperature indices also developed. Now these indices help in describing the climate change impacts on human health, agriculture, and then environment, and we can formulate long-term policy measures. Even the heat wave and cold wave conditions can be tracked using these indices. So the red one shows the maximum temperature data, and the blue one shows the minimum temperature data. So if I want to calculate the average temperature, so at a particular day or particular time step, I will just average out Tmax and Tmin, that will give me the average temperature. So here we are talking about daily temperature, which is daily average temperature. If I take the difference between the Tmax and Tmin, so that becomes diurnal temperature range called DTR. So your DTR is T max minus T min. It will give you an idea about the fluctuations happening in a particular day, that what is the maximum and minimum range. Now if I want to quantify heat waves as per IMD criteria, if you are in plain region, 40 degrees is the absolute threshold for heat waves. So how many number of times my T max has crossed 40 degree, so if I put that threshold, so I get number of heat wave days. And if I want to do on cold waves, then 10 degrees is the threshold, so number of days, so it should be T minimum here, there is a typo. The number of days where T minimum is less than 10 degree, that will give me the cold wave day frequency. So likewise other indices can be calculated and we can get an idea about these temperature extremes. Coming to the geospatial data, so geospatial data provides a very valuable information on the specific location, that is using the latitude and longitude. So these coordinates are very important to describe any information. However, geospatial data is available in two formats. One is a raster and second is a vector. So a vector is used to get very precise information and it is represented in terms of points, lines and polygons. So they represent discrete features, like if there is a road or if there is a house, if there is a tree, so that can be represented. But raster, they are used to represent continuous data in grid cells. So if you have continuous data, you can just represent that particular thing in 1 by 1 pixels. Further, what are the technologies to collect geospatial data? The technologies are GPS, that is it will provide location information, then GIS, it will provide information on the lat long, so you can map it very clearly, and drones, which are used as a very mobile data collection platform, and it can be used to access inaccessible areas. If they are fitted with high resolution cameras or LiDAR, that is laser based technology, so then it can give you more information as well. What are the applications you can use for urban planning, urban waste management, vegetation monitoring? You can monitor infrastructure progress, natural disasters, you can use it, which is our main focus. So how GIS can improve disaster mitigation? With the help of GIS, for pre-disaster, you can identify the hazard prone areas, so you can clearly say that these areas are more vulnerable depending upon the many factors, whether they are low lying or their proximity to the river or proximity to oceans, or they are located on steep slopes. So based on the hazard which we are quantifying, their vulnerability can be mapped. Once you have mapped the vulnerability, now you should also take into consideration that in case I need to evacuate, what are the possible evacuation routes, so that evacuation routes need to be identified. Once that is done, we can also compile a database of people at risk, like children, then you have old age people, those who are ill people, so if there is a nearby hospital, school, and any other place where people are at high risk because of their inherent conditions. So if in case you need to plan an evacuation, so these people will be the first priority for that. And that information, if we collate before any disaster, it will help us in smoothly navigating such disaster. Then during disaster, your remote sensing will give us real-time information, that how the cyclone track is moving, or which areas are affected by cloudburst, what is the cloudburst intensity. That information we can get it to gauge the extent of that disaster. Now once we know this data, we will find the spatial extent, that which locations have been impacted, what critical infrastructure have been impacted by this, and that will help us in relief and rescue operations. So now there is sometimes, like in case of landslide or flood, the connection that is a physical connection through roads or any other modes of transportation is being distorted. So what we need, what can be done in that case? Drones are very effective, because drones can fly and they can capture the imagery required, or nowadays drones are used to give essential supplies also. Obviously helicopters and others are there, because if the weather does not permit, helicopter cannot fly. So in that case, drones can be used to give essential supplies, and that can be made more accessible. And lastly, post disaster, what can be done, that we need to understand or map the extent of area that is damaged. So if you are providing insurance losses or insurance cover, so that can be noted. Also climate proof infrastructure. So if our infrastructure is recurrently affected by disaster, how can we climate proof them, or if there are requirements to amend the land use planning. So what are the highlights of this week's learning? We understood that what is the importance of hydroclimatic measurements to understand the climate change effect and to map our water resources. Hydroclimatic data is available in different formats such as point data, gridded data, then your reanalysis data, then geospatial data, that is remote sensing data, and the projected data. If we using this hydroclimatic data, we can analyze rainfall and temperature extremes, and we can use it for diverse purposes including climate change impact assessment. Then we will use the geospatial data because it is highly effective in capturing large area characteristics in a very precise manner. So we can prepare hazard maps, vulnerability maps that can help us pre-disaster and during the disaster, as well as the post-disaster planning also can be done. So this is a very important tool. And we also saw several case studies where this GIS and remote sensing can be leveraged effectively to safeguard the lives of people, and because that is our topmost priority. Infrastructure loss is inevitable, but we have to safeguard the life of people. That is our topmost priority, and that is where these technologies are widely used. So next lecture will be a hands-on session. So let us see what we'll be doing on this hands-on session. So we'll be downloading the gridded rainfall and temperature data from IMD. The rainfall data is available at 0.25 degree from 1901 till 2024, and the temperature data is available at 1 degree from 1951 till 2024. So we'll be downloading that data, then we'll be processing that data. We'll select a area of interest. So for that area of interest, we should identify how many grids are covering that, so that we will identify. Then we will derive some extreme rainfall indices, like it can be PRCP, rainy days, maximum one-day rainfall, 95th percentile rainfall, R95P, and frequency of heavy rainfall or moderate rainfall. Some indices we can derive. Then similarly we can derive temperature based indices like maximum temperature, Tmax, Tmin, then DTR, diurnal temperature range, T average. If we want to quantify heat wave frequency, then Tmax greater than equal to T40, that is, and cold wave frequency where Tmin is less than equal to T10. So these things we will cover. And lastly, after deriving these indices over a period of time, we can prepare spatial maps to show the variability of this climate index extremes. So we can identify that which regions are more prone to heat waves, which regions are more prone to floods, which regions are more prone to cold waves, and also prone to droughts. So that can help us in your pre-disaster planning, that we have identified that these regions are prone, and whatever relief operations have to be carried out, so we have to carry out considering these particular regions. So these are some additional learning resources. If you want to explore more about the indices, so this ETCCDI has provided a list of all indices, so that you can explore. And if you want to see how calculation of indices can be done, so there is an inclined portal developed by IIT Mandi. So you can visit this portal and you can select any particular location, you can select the variable, you can select the index, or you can give a area of interest also, and it will give you a time series for the historical period and for the future projections SSP 245 and 585, that how a particular, so this is for TNX, so it indicates that number of cold nights, so number of warm days and cold nights, so that you can get it. Similarly, you can get diurnal temperature range or rainfall extremes also based from this portal. So it will give you a proper visualization. So thank you for your attention. In the next lecture, we'll be working on the downloading and processing of gridded rainfall and temperature data using MATLAB. So thank you so much.